So this might very well be the kind of question that you have done the most times in your life. I'm given 2 points, and we're asked to find the equation of the line through them. Whenever you're given a question like this, the first thing you want to do is figure out the slope. Because remember, our answer is going to look like y equals mx plus b, unless our line turns out to be vertical. But I'll leave it to you to check this line's not vertical. And so if we calculate the slope, that'll already get us halfway there. And the way we calculate the slope is, remember, change in output divided by change in input. And 2 points are exactly what I need to calculate this change. So remember, again, the y-coordinate is the output, and the x-coordinate is the input. And so as I went from this point to 7 to 5 minus 5, the output changed by minus 5 minus 7. That's the change in the output. Okay. That is, if you like, the output here got 12 smaller. That's why this is a negative 12, because the output changed from positive 7 to negative 5. Okay. And the input changed from 2 to 5. Okay. So if I just leave this literally as is, what happened to the output is that it went down by 12, which I mark with a negative 12. And to the input, it went up by 3, which I mark with a plus 3. And so this is how I calculate my slope. And I can, of course, simplify this because negative 12 divided by 3, that is just minus 4. And so that is my slope. So what does that tell me? That tells me the equation of my line looks like y equals minus 4x plus b. Now, I'm going to be done once I know what b is. Remember, there's still going to be a y and an x. I don't need to solve for those in this case. I just need to figure out what b is. And there's a couple ways to do that. One of those is to use what's called point-slope formula. And if this is something you were taught or something you like or something you want to look up, by all means, you're welcome to use that. I won't complain. However, one thing that is true about me is that my memory is terrible. And so I use as few formulas as possible, and I can get away without using this formula. So I'll show you a different way to do it that doesn't require learning a new formula. And here is that way. Namely, 2, 7, we know, is on the line. Okay. And what does that mean? That means that if we plug 2, 7 into this equation, we better get something that's true. So we can, and I know everyone loves this phrase, we can plug it in. Okay. And so when we do that, I plug in the 7 for y, and I get that that's equal to minus 4 times 2 plus b, whatever this b happens to be. Okay, so 7, that's minus 8 plus b. So b is 15. And so now I know what my b is, and so the equation of my line is y equals minus 4x plus 15. And that is the equation of my line. Now, there's one question that you might naturally ask, and it would be a good question, which is, why did I pick this point instead of the other point, 5 minus 5? How did I know that this was the one that would work? Well, the answer is actually that it would work out exactly the same way no matter which of these 2 points you chose. And in fact, there's a really good way to check your answer here, which is to check that if you plug in the point you didn't use, that is, to check that if you plug in 5 minus 5, that it actually works. And so that is, you want to check that minus 5 is the same thing as minus 4 times 5 plus 15. And wouldn't you know it, this is minus 20 plus 15, that's minus 5, and so we can check this off. And then having done that, we can be pretty darn sure that our answer of this equation is the right one to give for our answer. In this question, we're asked something very similar. We're asked to find the equation of the line through 9, 3 and 9, 7. But this question is fundamentally different than the previous one, and I'll give you a minute to think about why that is. See if you can see it before I spoil it for you. What's special about this line? This line is vertical. How do I know it's vertical? Well, the x-coordinate here and the x-coordinate here are both the same. And so if you want to think about where these points would live in the xy plane, you'd go over 1, 2, 3, 4, 5, 6, 7, 8, 9, go up 3, that would be 9, 3, and then you'd go up 7, that would be 9, 7. And what do you know? These 2 points live on the same vertical line. Okay. And it's hopefully clear what the equation of this line is, because we can think about what these 2 points have in common. Namely, they both have in common that their x-coordinate is 9. And so the answer to this is just x equals 9. So if you're on your toes, you can see this one and sort of call this out right away. By the way, if you happen to see that the 2 points requested were, say, 4 minus 2 and 7 minus 2, you could make the same observation. Namely, you could notice that what these 2 points have in common is that their y-coordinate is both minus 2. You could do the question this way, but you don't have to. You could just immediately jump to, oh, these 2 points both have y-coordinate minus 2, so the equation of this line is y equals minus 2. Okay. So both vertical and horizontal lines, if you look for them, will sort of leap out at you. But some of you who are watching this are thinking, okay, but what if I don't notice this? It's great if you do, but it's easy to let this kind of thing sneak by. If this is the third or fourth question you're doing, maybe you've stopped checking. How would you know if you started to do this method? How would you know that something had gone wrong and that you were looking at a vertical line? And here's how you know. If you start with this method, what's the first thing you do? Well, you calculate the slope. So if I do that here, in this example with 9, 3, and 9, 7, because I'm an unsuspecting person who doesn't guess that this line is going to be vertical, so I go ahead and calculate the slope. There's going to be the change in the output, which is going to be 7 minus 4, divided by the change in the input, which is going to be 9 minus 9. And so that is the output changed by plus 3, while the input changed by plus 0. But here's where something has gone awry. Namely, the input is the same for both, so the change in the input was 0, and so this is a fraction where there is a 0 in the denominator, and zeros in the denominator are bad. Namely, you end up calculating that this is undefined, and so you get that, hey, this line is the kind with undefined slope. That we said earlier was the vertical lines. And so then you go, oh, hey, this line's going to be vertical. It's going to have an equation that looks like x equals something. And then you look and go, it's x equals 9. And then you're in good shape. One more thing to remind you about with lines is how these things with parallel and perpendicular work. So you might see questions that look like, find the equation of the line parallel to this line, but passing through this point. And the key thing here to know is what parallel means in terms of lines. And so what does parallel mean? Parallel means that the two lines have the same slope. And so this is the fact that is maybe buried somewhere deep in the back of your head. If you haven't thought about this for a while, parallel lines have the same slope. And so when we say, hey, find the equation of the line parallel to this, but passing through this, then I can read off immediately, the slope of this line is 2, so the slope of the line I'm looking for is 2. Again, I just read off the two. The lines are parallel, the line I started with and the line I'm looking for, so they have the same slope, namely 2. So that means that my equation is going to look like y equals 2x plus b, and I just need to figure out what this b is. Now, I talked to you before about how one way to do that is to plug in the point you know. So I could plug in 0 for x, 7 for y, and then solve for b. It won't be too bad. You'll get the right answer. Everything will go well. But, again, if you're paying attention, you can skip that, because what is this point? Well, this point has an x-coordinate of 0. And what are points that have an x-coordinate of 0? Those are points that are on the y-axis. And so what that means is that this point, because there's a 0 here, this is actually the y-intercept of our new line. And so this b in y equals mx plus b, I can just read it directly off of this point. This 7, that's b. And so the equation of our line is, in fact, y equals 2x plus 7. And that is our answer. Okay. Again, if you don't notice that, nothing harmful happens. You just go through a little bit more algebra of plugging this point in and solving, and it's not too hard to solve because the thing you plug in for x is 0, and then you're almost there. Okay, similar question now. Let's find the equation of the line perpendicular now to the same line, 2x minus 3, and passing through the origin. Remember, the origin is the point where the coordinate axes meet, so this is the origin. And so to do this, we need the analogous fact to the fact that parallel lines have the same slope. Namely, we need to know what's true about perpendicular lines. Okay, and the thing that's true about perpendicular lines is that perpendicular lines have negative reciprocal slopes. And that's maybe not everyone's favorite sentence. So what this is saying is if you start with a line with slope m, a line that is perpendicular to it has slope minus 1 over m. Okay. And so the minus is the negative, and then the reciprocal is saying 1 over that. So in our example, our original line has slope 2, and so that means our new line has slope, well, negative 1 over 2, which means that our new line has an equation that looks like y equals negative 1/2 x plus b. Okay. And do we know b? Well, in fact, if we think about it, we actually do know b, because what are the coordinates of the origin? Well, this is on both the x and y axis, so both the y and x coordinates are 0. The origin is just the point 0, 0, which is probably what you thought of when I said the origin. So in particular, the origin is the y-intercept, and so this 0 here is b. And so the equation of my line here is y equals minus 1/2 x plus 0, although adding 0 doesn't do anything, so normally we just write y equals minus 1/2 x, box that in, and call that good. In fact, anytime you go to look at an equation of a line, if you want to know whether it passes through the origin or not, when you look at something with y equals mx plus b, the plus b is 0 exactly when it passes through the origin. So anytime you have y equals something times x with no plus b, those are the lines that pass through the origin. All right, I'll wrap up this video for now. In the next video, I'll go over a few trickier types of line questions, just to review a couple other kinds of questions that are going to be popping up with lines, where maybe the way they're phrased or whatever makes it sound more difficult than it actually turns out to be. But for now, I'll see you next time.